Very good evening to all of you. Welcome you guys. Welcome you all. How you are doing everybody? कैसे हो सभी लोग? We are doing everybody. Tell me now first of all. Hope you are doing great. First of all, you please confirm is my audio video is clear to all of you. Yes, audio video is clear to everybody. Tell me first of all. Chalo, let's start our discussions all of you. Chalo. So here we have one great announcement from Unacademy. So you can able to avail the great discount. You can able to avail it. See, you can see now here. You can see now here the top educators will take the classes. We are starting a new batch. This Brahmastra batch. You can able to get the great discounts are waiting for you. So you try to utilize this opportunity before this offer going to expire. The new batch is commencing from the 13th October onwards. These are the top indicators. You can get up to you can able to save up to 50%. You can able to save if you have taken the available subscription now. So you can get flat 30% discount. In addition to that, additional benefits are there. Have a look at now by taking the 4 months, you 1 month additional, and by taking 6 months, you'll get additionally 2 months, and for 12 months, you'll get additionally 3, and 12 months, you'll get additionally 4 months. आपको मिलेगा. Utilize this opportunity. Now there are the new batches starting from the 13th October onwards. You can have a look at now. We're starting with the general aptitude, the most important subject, which is a very scoring subject for all the branches. You can have a look at now. These are the new batches we are starting. The top educators only will take the classes in these batches. Have a look at here. Right, and we are starting the exclusive batch for the AI and DS के लिए भी. So this is just the double nine. You will get this complete course. And these are the plus features. You can have a look at here. The plus features: raise the hand options, class doubts, in polls, daily practice, educator community, and you can able to follow my educator community. You can get the daily updates about my classes. And tomorrow we are onwards we are planning this as a special classes also we are planning. And in live interaction, PDF material, unlimited access to the material that the top educators will take the classes. You know, and you can plan the subscription with a no cost EMI also. Without paying additional charges, you can able to avail it. And you can have a look at now here. Daily scholarship is also available, and try to utilize these opportunities. Fine, चलो आज का सेशन हम शुरू करेगा. And this is a so here yesterday we have started some this network course. We have discussed some of the topics. We have discussed some problems हमने discuss किया ना. As I told you ना, this course is both in the YouTube and special classes में होगा. Okay, YouTube and special classes. And tomorrow onwards we are starting the special classes also. We are starting. So you can see now tomorrow we have a special class at 9 a.m. At 9 a.m. we have a special class on these networks. Okay. So चलो हम शुरू करेगा आज का सेशन. Tomorrow 9 a.m. and evening we have a YouTube session. Same timing 7:30 p.m. we have a class. So चला शुरू करेगा now here आज का सेशन. So yesterday we have completed some of the problems. So यहाँ तक प्रॉब्लम हमने कंप्लीट किया. बोलिए यस. नाउ अगर कोई डाउट हुआ तो पूछो जल्दी फटाफट. You have any other queries you can tell me. चलो यहाँ तक का टॉपिक में कोई डाउट हुआ तो पूछो जल्दी फटाफट. चलो हम कंटिन्यू करेगा. चलो Now, so tell me now here next problem. Find RAB, the equivalent resistance they are asking to find. Tell me now equivalent resistance in this case. The three circuits has been given. We need to find the equivalent resistance in all these three cases. Yeah, try to find out the equivalent resistance in all the three cases. Get now here. Now here this is given as A. So इसका यहाँ से यहाँ तक there is कोई element नहीं ना. So this means this is also called as A only. And this is calling it as what to tell me now B. This is calling it as a B. And this is calling it as what, tell me B. A B होगा ना, tell me. Now you can see now here. So here if you see this thing, we have three resistors. So this point is A and all the three resistors are between A to B में है ना, between A to B में है. So इसीलिए क्या बोलेगा इधर, how this all the three resistors you tell me parallel, how is all the three resistors you tell me now parallel में है ना. So that's why RAB क्या बोलो, this is R by 3. RAB is equal to how much you tell me, R by 3. Everybody got it? All of you. Everybody done it? See the next one. This point is what you tell me now here, A. And you see this point is given as B. So A point B है ना. Why? Because there is no element here. A point B होगा and A B होगा ना here. This all the elements has been connected. You can see now all the four resistors are between A to B में है ना. All the resistors are between where to where, A to B में है ना. So this means RAB, which is given as what I can say, tell me R by 4. All have to tell me this thing. So be given as, we can say R by 4 होगा. Hmm? Completed. Now tell me the third question. Next one. Tell me now here. This point is A either, same as earlier. Now this point is B. Now you tell me now here, this point is B. Can you say this point is also B? No. Why? Because इसका बीच में कोई element है ना. So इसीलिए this is not B. Let us say कुछ और ले लो. I have taken some other thing. Okay. C, and this is C, and this is C. Isn't it? Now you tell me now here, how these resistors, you see this thing here. So I will redraw this thing for easy understanding purpose. Now here this is my A, and somewhere I am taking this as a C, I am taking, and this I am taking this as a B. Now connect these elements now here. You can see now between A to C I have this resistor I have connected here. Between A to C I have this resistor, and this is between A to C. between A to C we have. Next, this is between A to C. Between A to C. Now I have three resistors are there, R and this is my R. Now weigh this resistor between B to C or A, C to B, both are same only now. So I'm connected here. And this is between B to C, connected here. Now you tell me now here. We need to find the equivalent resistance now here. How these three resistors are now parallel. So equivalent is what I can say, tell me now, R by 3. And this is R. How these two are, tell me now here, R by 2. Now these two are series mein hai na. So from this what I can say now here, RAB. So from we can write RAB equal to what, you tell me? AB, which is given as these two are series mein, R by 3 plus R by 2. This value tell me 5R by 6. Got it all of you, tell me? In this manner we can find these resistances. Okay. Hello, next problem. Take down. The equivalent resistance between the terminals A and B. The equivalent resistance between the terminals A and B is, tell me now how we can find the equivalent resistance between the terminals A and B. Actually here this connection is not there. The connection. Now you can see now here, redraw the circuit now here. Try करो. क्या हुआ connection? This another element is like this. Right. So you can see now this is 1 ohm. And this is 6. And this is 0.8 ohms. And this is 3 ohms. Now this is 3 ohms. And this is 6 ohms. Now you can tell me now here. Now you can see now here what we can do. If you see carefully, this node and this node both are same. Yes sir, now tell me, these two nodes are same. So what I can do here, this resistor, this blue resistor which is between here to here, now simply removing this resistor, blue resistor, connection मैंने remove किया this thing. So instead of here, now can I do this connection to here only? Right. Next, this green one, This connection also I am removing here. This connection remove करके मैंने इधर प्लेस किया. ओके, दोनों सेम ही है ना, बोलिए. Now you can tell me the connections. Now you can tell me how we have this interconnections. You see this thing here. These two are in series now here, which we can say this has a 2. Now these two are also parallel, which will come it as what? Tell me now here, 2 now. Which will come it as what? Tell me. Which is equal to 2 ohms. And these two are parallel में हुआ. The equivalent will come it as what? You tell me now, 2 में आएगा. Now you can see now here how we have the resultant value. Here 0.8 is there like this. ऐसा हुआ ना. 0.8 ohms. You see how much this value? Tell me that. Here now. So this value how much now here? This is 2. And how much this value here? This is 2. Okay. Now you can tell me now here how these two are now here. These two are parallel, which will come it as a 1. And this 1 and 2 are in series, which will come it as a 3. Now the 3 and 2 are in parallel, which will come it as what? Tell me. Finally we can write this as RAB, which is equal to 1 plus, now we can say 3 parallel to 2 plus what we can write now here, 0.8. You can say this is 1 plus 6 by 5 plus 0.8. So you can simplify this thing. How much will get now here? Answer, tell me jaldi. 1 plus 1.8 and this value you tell me now here, 1.2. So this is 1 plus 1 point, isn't it, plus 0.8. Check it all of you. How much will get now? 3 now. How much this value here? 3 ohms, isn't it? Done this thing. Next problem. An incandescent lamp is marked as 40 watts to 40 volts. The resistance at room temperature is given as a 26 degrees centigrade is 120, and temperature coefficient of resistance is given as 0.5 into 10 power minus 3 degrees centigrade per degree centigrade. They ask him to find the on state terminal filament temperature. Tell me now here. Initially, this is the rated power. The rated power is given as how much? You tell me now here, 40 watts. The rated power is 40 watts. Now you tell me now the rated power which is given as what we can say this is V square by R. V square by R. Can you tell me now here R value from this? R which is given as what we can say here V square. How much now? 240 into 240 by 40. Can you tell me how much this value? This value tell me. यार कैलकुलेशंस करो यार. अगर कैलकुलेशन किया तो भैया जल्दी जल्दी हो जाएगा ना. बिना कैलकुलेशन कैसा चलेगा? जल्दी फटाफट कैलकुलेशन करके बोलो जल्दी फटाफट. All of you do it now here. Simplify. Try to simplify this value. So this is 1440 आएगा. Calculations करो everybody. Now here, now this resistance at room temperature is given as this much. As we know, the variation of temperature with respect to time, which is temperature, is given as R equal to R naught into 1 plus alpha into delta T is the change in temperature. So how much is R we got now here? That is 1400, which is given as R naught is how much? At room temperature, resistance is 120. That is 1 plus alpha is how much we can say here? 4.5 into 10 power minus 3 into delta T is the change in temperature. What is the change in temperature now here? T2 minus T1. How much it is a delta T? T2 minus T1. T1 is given as, we can do simplify this thing, 26 degree centigrade. Simplify now here. So this is 0 cancel. So this is 12 12s. And simplify this value क्या आएगा? Tell me. We'll get that T2 minus T1 आएगा. Tell me how much we'll get. This is 1 if you do here. So that means what we will get now? T1 if you do, which will get it as a something 11 by 0.5 into 10 power minus 3. Check it all of you. We'll get the T2 minus T1. Final answer you are giving. T2 minus T1 is how much? Yes, 2,444. So that means T2 is given as what you tell me now here? 2,444 plus T1. T1 is how much? 26. So finally T2, which is given as what you will get now here? 2470 degree centigrade. So this is the on state temperature of the filament. Done. Chalo. Next problem. See this problem they given. A connection is made consisting of resistance A in series, series with a parallel combination of B and C. Three resistors of values 10, 5, 2 are provided. Consider all possible permutations of the given resistors into the positions A, B, and C and identify the configuration with the minimum possible overall resistance and also with the minimum the ratio between maximum to minimum ratio we need to find. Understood the problem all of you first of all? They has given the condition now here. I have the combination a resistance which is like this, and I have the parallel combination the resistors like this. Resistance value given as what, tell me? 10, 5 and 2 given. So I need to get the minimum and maximum I need to get. So to get the maximum, first of all, I can say the series resistance must be 10, I can say. Yes or no? अगर series ज़्यादा है तो कभी हम will get the maximum will come, isn't it? And thereafter, anyone we can take it as a parallel, these two. So you can tell me the equivalent resistance of this combination. If I call this as a R1, if I say that is 10 plus this is 10 by 7, which I will come it as what we can say 80 by 7 will come now. This thing. Now we are doing, you tell me now here. So let's try to get the same thing. What we can do here, tell me now. Place the resistance in the different to get the minimum के लिए. So tell me ना positions ना हुई है. तो ये क्या होना पड़ेगा? अगर मैंने इधर 2 ले लिया तो इधर 10, इधर 5 मैंने ले लिया. So tell me now this value, if I call it as R2 होगा ना. How much we can say this is 2 plus how much, you tell me now? 50 by 15, isn't it? So that R2 value 5 से cancel किया तो 5 3s 5 10s. So how much this value, tell me here? 6. Yeah, 6. So that is 16 by 3. इससे और भी कम होगा क्या? पॉसिबल होगा क्या? अगर इस प्लेस में मैंने 5 and 2 रखा तो क्या होगा? टेल मी दैट 5 plus these 2 here 20 by 12 होगा ना. So you can see now this value, I can say this as 4 3s 4 5s. So here how much will get now this value? 15 20 by 3. So you can see this value more compared to this thing ना. So ये value minimum हम बोलेगा and ये value तो maximum होगा ना. So अभी they tell me now, they asking to find the ratio, means what I can say now, R1 by R2 ratio पूछा. So what we can say now here, 80 by 7 into what I can say 3 by 16. Tell me how much this ratio? Hmm? 10 5s na here, 15 by 3, 15 by 7. How much will get now? Something 2 point something. What will get? 2 point something will come now. Yes, 2.14. 2.14. This is the answer we need to enter. Okay. चलो next problem. Yes. ये problem करिए. This problem. Now take this problem here. How we can solve it now? Locate now here. And first of all, you do remember, if we have some resistor is there, whenever there is any shorted path is there for this resistor, Then see what happens now here. This current, if I call this as I, and the complete current will flows here only. Complete current will flows here only, and the current passing through this resistor is how much we can say 0. No current will pass. If there is no current will pass, then what is the voltage across this element? You tell me now. 0 volts. And the voltage 0, current 0, then that element is called as a dead element. Voltage 0, current 0, that element is called as what? Dead element. This dead element does not affect the circuit operations. Equivalent resistance calculation में affect नहीं होगा, इसीलिए we can remove that dead element. So सबसे पहले इधर you see this thing here. So जो current इधर आया पूरा current इस path में जाएगा. Complete current will go in this path. So the what is the current through this element? You tell me now. 0. It is completely 0. There is no current is passing through here. Fine. So means we can call this element is called as a dead element. Dead element we can disconnect from the network. Okay. So you can do it now here. Now let's see one by one element equivalent calculations. First we are finding what you tell me now here. This is RXY. Now R2 X2Y का path देखो इधर ध्यान से. X2Y का path. So ये element तो नहीं ना here. This is X current I आया. So finally current has to reaches to the point Y. Now you see this path you see here. So this is now X. Current यहाँ से इधर आ रहा. Going like this. इसके बाद so this current is going. कुछ current इस path में भी जाएगा ना. There भी resistance है. And इधर कुछ resistance है ना. ये था path ना. Tell me this is my Y. And how much is value now? 3. And this is what you can say 6. And this is 1. Now can you tell me now here? The equivalent resistance now here. What are the current is coming? The same current will flow now. So this is RXY. You see this thing how these 3 and 6 are in parallel. So this value that is 2 plus 1 hoga na. How much this value? 3 ohms. Everybody got it? Next. Tell me the next one is what? Tell me now here. We need to find R X Z. X2Z you tell me. And X2Z. Path देखो X2Z का path. So this is starting point is from the X. The current starting from X. So this current which is simply coming to the Z now here. The current which is coming simply to the Z. So this current does not face any resistance. So tell me now here how much this current. You tell me now this current is what we can this. There is no resistance now here. Complete current will go in this path only. Complete current will go in this path only. There is no resistance now here. So RXZ. How much is RXZ? You tell me now here. 0. Tell me. Yeah, fine. How are you? After a long time you are coming to the class now. Next. Next one is what? Tell me now here. XP they are asking to find. Tell me the RXP. Yes, this class will be run at till 8:30 na. So the YouTube class is 7:30 to 8:30. That's why I planned this as network class is at 9:30 p.m. X2P, tell me now, this is X and this is P. Tell me now here the connections here, the current, see the flow of current, you tell me now here, this path and this, after this current here is there, this point is P. Now see the what else, the other path also will come here, and this current is this value, this is 5. Now tell me this current is X. Now you see this thing here, this other path can doesn't reaches to the point P, right? So this current, so this is the current will go in this path. How much the resistance you tell me in this path? X2P resistance is how much here? 7 ohms. X2P resistance is how much? 7 ohms. Next, tell me now here RYP, Y2P, Y2P. These classes will be run in the YouTube as well as special classes. The two classes we had now, this is on the YouTube, and tomorrow we have a special class also we have at 9 a.m. Tomorrow morning we have a special class at 9 a.m. Y2P. See the Y and P path. Special class. YouTube class is this time, and in addition to that, special class is also there tomorrow morning. And this is a shorted na here. Here onwards, this current will go like this. Okay. Okay, then we'll plan. Tomorrow onwards, we'll plan. Tell me the equivalent resistance here in this path में क्या है? And you can see now here how these two resistors are. You tell me now here. These two resistors are in series now here. Tell me. Sorry, parallel. So how much this value? Tell me 2. So tell me now RYP. RYP, which is given as, we can say here 2 plus 5 plus value. Tell me. So this is 10 ohms. Got it? ZP, Z2P, tell me now here for this network. Z2P, you tell me. क्या है Z2P? This is my Z and here this is the P. You can tell me now here. This flow of current will takes place from Z2P. The path we can see. Yes, ऐसा जाएगा. And this is the Z ना here. The shorted path में जाएगा. This is a P and here this is the 2 ohms. And here this is a 5 ohms, I can say. टेल मी नाउ जेड टू पी, ए पाथ में करंट जाएगा, सो दैट मीन्स आर जेड पी, how much we can say this as 5 plus 2, this is 5 plus 2, how much you tell me now? 7. You tell me now, this is RAB, the resistance between A to B. Tell me the resistance between A to B here. Here this here. This is A. Here this is B. And this point is B. Now see the of current from A to B is path. Is path current. Yes. And here is a shorted path is there. Now you can see this is the 5, this value 1, and this value 4, and this value 6, and this value 3. Now you can see these two are series, and thereafter this value how much now here 9, but this 9 and short is parallel, so will becomes what? Tell me 0 hoga na. Tell me now RAB, which is equal to 1 plus 5 plus 0 plus 4 आएगा, which is equal to 10 ohms, right? RAY, tell me A2Y, tell me A2Y, and Y is here. Yeah, tell me the path, identify the path here. This is A, so this is Y. Now tell me now, this is 1 and this is 5. Now here this is 3 and this is 6 and this is 1. Tell me how much now here? 5. So you can see now here 1 plus 5 plus 3 and 6 are parallel now here. Equivalent is 2. So this is 2 plus 1. How much is value? 9 ohms. This is RBY. Tell me now RBY, B2Y. Here is a B now here. Tell me path. B2Y. रेड पाथ है ना, ये वाला. नहीं भाई, is how much you tell me now? 3 and this is 1 and this is 6 and this is 4. Tell me how much is value? Now these two are parallel, right? So how much is value? Tell me now. 2 ohms. Now you can tell me now here BY, which is equal to 4 plus 2 plus 1 is equal to 7 ohms. That is, tell me now RPB, P to B. So here is a P and here is a B. Tell me now RPB is path. Tell me now here flow. Okay, so this path not is required. So it will go via the shorted path and thereafter B now. This point is P and this point is B. Now you see this current is what, tell me 2, and this resistance is given and this resistance is 4. This path we need now, tell me. So tell me how much is the RPB value, which is given as 2 plus 5 plus 4 is equal to 11. Now tell me now here Px, P to X. Tell me the path now. This is the B. This the X will come here and this is a B. Now tell me B यहाँ से इधर आया and this point. This is X. This point is B. This value how much now? 4 ohms. Now B to X. How much you tell me now here? RBX, which is equal to 4 ohms. What did all of you tell me? We are solving these problems. This is the way we need to solve these problems, right? Chalo. Now, see the next problem. Now, अभी तक हमने basic problems हमने complete किया. Now let's enter into the next type, another type of problem, that is ladder problems. We'll call infinite ladder problems. Take down this is. Find the input resistance of the infinite section network. Resistance we need to find out. Yes, tell me now here. This type of network is called as infinite ladder network. In this type of cases, we need to see where the same part of the network is repeating. Okay, अगर आपने ध्यान से देखा तो इधर you can see now this part of this network, this part repeating. Now tell me ये वाला. We can understand now here this part of network. This is one part of network and this is the other part of network. This is other part of network. Like this it is repeating. Now tell me this part of networks are repeating. So we'll divide them into parts. Like this, how many are there? Like this, infinite are there. And I'm disconnecting the first part of network. I have disconnecting from the network. But disconnect the first part of network. Disconnecting this thing here. The remaining part of the network is as it is hoga, isn't it? Remaining part. So this means disconnected first part and the remaining part is as it is, aisa hua. Now this is what I can say 1, and this is 1, this is 1, 1, and this is 1, and this is 1, like this continue hoga. Okay. Now we are removing the first part of the network. I am removing here like this. How many are there? You tell me. Infinite are there. The equivalent resistance whole part is what? Tell me. Equivalent resistance of this whole part is what? Tell me. Resistance of this whole part is what we can say here. This is what we can say R only na. Resistance of this whole part of this network. This part, which is nothing but what we can say the whole equivalent resistance is. If I call this as R equivalent. R equivalent if I say. Now tell me now here, if I remove this one part of this network, कोई problem नहीं होगा ना. Infinite minus 1 is infinite only, will consider na. This resistance is also R equivalent only. Now that means इसका मतलब क्या है? The equivalent resistance of this whole part of this network. The whole part is what you tell me, this whole part of the network is R equivalent only. So I can redraw this network as like this. I can redraw this thing as like this. 1, this is 1, this is R equivalent. And this equivalent of this whole part of this network is R equivalent only. ये बात समझ में आया? बोलो आपको. What I can say now, this is R equivalent here, which is equal to, so this is 1 is, so now these two are parallel now here, so that is 1 into R equivalent by 1 plus R equivalent hoga. Finally this is R equivalent is given as, we can take LCM and simplify here, 1 plus R equivalent plus R equivalent by 1 plus R equivalent. Tell me this thing. Now cross multiply and do simplify this thing. If I cross multiply this thing here, this is R equivalent, which is nothing but 1 plus 2R equivalent by plus R equivalent. 1 plus R equivalent. And cross multiply and simplify this thing here. R equivalent plus R equivalent square, which is nothing but 1 plus 2R equivalent. So this means, which we can say R equivalent, quadratic equation banega. R equivalent minus 1, which is equal to 0, isn't it? So we can find the roots of this equation. R equivalent, which is given as minus b, that is minus 1, so minus plus 1 plus or minus root of what we can say b square minus 4ac by 2a. Finally we will get this R equivalent as minus 1 plus or minus root 5 by 2. So we will get like this is R equivalent, which is given as, we will get it as, if you take negative values not acceptable, so we have taken positive values, minus 1 plus root 5 by 2. This is my R equivalent. So this is one of standard formula, you can able to remember this thing. So equivalent, which is given as what we can say here, root 5 minus 1 by 2, standard formula. Here you can see now here how much these resistances are, all these are 1 ohms now. Agar these values instead of 1, if this value is something, let us say R, and this is R, all these values are R or high to, then the equivalent resistance kya hoga, R equivalent is multiplied by R. Yes, root 5 minus 1 by root 5 minus 2. So here this is a R equivalent होगा. Okay, root 5 minus 1 by 2 into R. ऐसा try to remember these relations. चलो next problem. Write down this. The equivalent resistance in the infinite ladder network shown in the figure is RE. In this problem, अभी नहीं हमने देखा. You can see. You can tell me now here. This is I have a 2R is there, and this 2R which we am splitting it as a R and R we are splitting. Now tell me. Splitting it as what? Tell me. R and R. The remaining network is same. This is also infinite network. You tell me here. This is R R R. अभी ने देखा ना ये नेटवर्क को हमने. Like this we have infinite. This value R. So this network we know the equivalent resistance of the whole part of this network. Just now we have seen this value. And we need what? Tell me now here. Equivalent resistance of this part, they are calling it as RE. So tell me now how much is RE value? Is nothing but what I can say R plus, just now we have seen that is how much here? Root 5 minus 1 by 2 into R. Tell me now, simplify this thing. RE value, which we can say this as, this is 2R. LCM 2R, or we can say R common. So then it is R common, so it will becomes what? Tell me now here. 2 plus root 5 minus 1 by 2. You can check this value. So I can get this RE value as what? Tell me RE by R, which will get. Okay. Got it, all of you? Like this will come. Second, previously क्या आया? Plus ना minus b. Sorry, this is plus here. Plus root 5 plus 1. Sorry, root 5. Sorry, this is root 5 plus 1 now. So this is plus 1. So how much this value? Tell me 3. Check this thing, all of you. 3 आएगा. क्या हुआ? क्या डाउट आई बोलिए आपका? यस, सो हियर ना ये प्लस ना हमने माइनस ले लिया ना, सो इसीलिए 5 plus 1 not minus 1. Okay. Yes. Then tell me now here. Yes, in this manner we can do. And tomorrow we have a morning class, the special class. Remember, special class at 9 a.m. Tomorrow we have a morning special class at 9 a.m. Okay, all of you remember this continuation of this class. Continuation of this class is tomorrow morning at 9 a.m. Okay, we can discuss, and I will try to cover the maximum problems. I will focus only on the problems only. Problems, and wherever the concept is required, we can discuss. Okay, chalo, and we'll meet in the next class. Okay, then see you tomorrow 9 a.m. Do follow this thing. See you. Bye bye.